I've finished the seat and the undercarriage. Now the top part of the Windsor chair is all the remaining work to do. That means steam bending a bow and turning some spindles. Unfortunately, the fine woodworking article we've been using for this series provides little information on this upper section of the chair, so I'll need to do some reverse engineering to assemble the top parts. The first thing to do is set an angled guide line for the bow at the seat socket. Using the sight line for the bow, I'll construct a small triangular face and set the angle according to the magazine article to 23 degrees. Using the protractor, starting the angle and typing 23. Now I can delete the triangle. The article also defines angles for all the spindles. I'll place another guideline for the position of the center spindle, which is shown at 8 degrees. Again, picking the protractor, and setting to 8 degrees. I need to create a canvas on which to draw out the shape of the bow. To do this, I need the other half of the seat and this guideline that we just placed. So I'll copy and flip and reconnect at the center line. Flip along the red axis. Zoom in to make sure I'm on the exact corner and connecting to the other corner. The bow is drawn on a plane defined by these guidelines running through the seat sockets. So using the line tool, I will make that plane on which the bow will rest. I'll pick an arbitrary height at first, and here is the trapezoid on which we can draw the shape of the bow. But first I need to check the height at which the center spindle intersects the plane. Typically for Windsor chairs of this style, the height of the bow from the floor is just a little bit more than double the seat height, something like 37 to 38 inches. Here you can see the guideline as it intersects the plane. I'm going to measure down to the floor. I need to measure on the blue axis, and that is too much, almost 39 inches. So I need to, that's too excessive. I need to knock that back, and what I will do is actually reduce the angle for the center spindle from 8 degrees. I'll just make it 7 degrees, 1 degree less than what was specified in the magazine article, and see how that looks. again, the magazine article has not provided a height of the bow or the length of the center spindle. Now you can see the reduction in height. Let me measure that reduction from this point intersection down to the floor. Okay, that is looking much better, 37 and 3/8, something like that. And that will work out quite well. If I can delete that 8-degree guideline, and I'm going to go ahead and reduce the height of the trapezoid to the intersection where the center bow intersects with the plane. Okay. And we have a canvas now on which to shape the bow. The article has not provided information on the shape of the bow. There's some pictures, but nothing we can bring into SketchUp and trace over. So by eye, we'll just set up a bow shape. I'll use the Bezier tool for this purpose and start it. I'll draw only half the shape since it's symmetrical. And usually there's a straight section at the bottom of the bow at a lower than the midpoint. So I've connected the Bezier tool at the two ends of the arc. And I'll set the top of the arc and then set the bottom of the arc here. And I think that looks about right. I may have it a little bit too sharp of a turn there at the lower section. I could do a little bit more editing on that, but it's good enough for now. I can delete the waist parts here and the guideline and the other half. I have already prepared a center spindle. I guessed at the length, and it's a good time now to check that length and how it fits with our shape that we've already designed. The article did not give us a length on the center spindles, and I know that pretty much how these things work, so I've guessed at a length. We'll position it now into the seat socket. I need to turn on X-ray so I can see the center point of the tenon that fits on the top of the seat. My tenons are usually 1 1/4 inch deep into the seat. Now to rotate the spindle, I'll use the rotate tool, position it on red color, and then grab the center line at the top and bring it over to the 7-degree guideline that we set. And that looks That looks like that's going to work quite well. Uh, the length of the spindle is enough that there will be a small protrusion above the spindle, which we need to have for placing a wedge. Now, there are angles also specified for all the other spindles. For example, this spindle is specified at 15 degrees. Let's see how that fits with our shape that we've created. Using the tape measure tool, setting a guideline at 15 degrees. Okay, it intersects very close to where we want it to. That'll probably work pretty well. And the next spindle has an angle specified at 12 degrees. Make a little triangle face. Grab the protractor. I think I said tape measure before, and I meant protractor. And type in 12 and see how that fits with our bow shape, bow center line. I want these spindles to run right through the center line of the spindle. Okay, that's better than the other one. That's coming right, almost exactly fitting. We'll do the others later in another part of the series, but for now that's enough that we know the shape is going to work okay. I'll make the bow shape a component called bow. And bring a copy over to the right for editing. We actually only have a center line for the bow, and we need the actual bow itself. The magazine article specifies a circular cross-section bow. I typically use a rectangular or square section, and the article specifies a 13/16 inch diameter for the bow. I'm going to bring a little small segment along the red axis just to make sure I'm square up here at the top, and place the circle 13/16 inches diameter as our profile. Now I need to select the path for the follow me. There's the arc, and there's the straight section. And I need to also pick that small straight segment along the red axis up here. Pick the follow me tool. And click on the profile. There we have the circular cross-section bow. We don't need that center face anymore, but I'll deal with that later. There's quite a bit of editing to do on this bow, and I'll leave that to another part of the series for the I'll just to see how this looks. I'll bring the other half into the seat and get a good look at how that shape's going to fit with a chair. I think it's going to be okay. Obviously that center plate and face is going to be deleted after we do the bow details.